today we will be learning how to find out whether the given set of vectors are linearly independent or linearly dependent using the concept of rank. Now, let us take an example. Check whether the vectors v1, that is 1, 1, 2, v2 is equal to -3, 2, 4, and v2 that is equal to 2, 4, and 8. We have to check whether these vectors are linearly independent or linearly dependent. Solution. Now, as we know, we have been given three vectors v1, v2, and v3. What is v1? 1, 1, and 2. What is v2? -3, 2, and 4. v3 is 2, 4, and 8. When it comes to checking whether the given set of vectors are linearly independent or dependent, we will starting with the concept of linear combination. Since we are having three vectors, let C1, C2, C3 are three scalars. See, we can take the scalars as C1, C2, C3. We can take K1, K2, K3. We can take any other than these symbols, as we are taking V symbol for vectors. So other than V, we can take any alphabet for the scalar. Now, we'll be having the equation C1 V1 plus C2 V2 plus C3 V3 is equal to 0 vector. So we'll be having this linear combination. We will be comparing that with the 0 vector. Now we'll be solving this, and if the answer for C1, C2, and C3 all becomes 0, then it will be as linearly dependent. And if if all the three are 0, then it will be linearly independent. If any of these three are non-zero, then we say that is a linearly dependent. Now we will be using today the concept of rank. That means we will be converting this in the matrix form, and we will be trying to find out the rank. If the rank of the matrix is equal to the number of this scalars which we are taking, then the given set of vectors will be linearly independent. And if the rank becomes less than these three variables which we are taking here as a scalars, if the rank becomes less than 3 in this case, it will be linearly dependent. So what we do, we will write C1 into V1 vector in the column format, 1, 1, and 2, plus C2 into the second vector, that is -3, 2, and 4, then plus C3 into the third vector, that is 2, 4, and 8. And we will be comparing that with the 0 vector of the same order. Is it clear? Now, if we want, we can write this as 1, 1, and 2, -3, 2, and 4, and then comes 2, 4, and 8. Then we will have the variables part, that is C1, C2, and C3, that is equal to 0, 0, and 0. This is the case of homogeneous equation now. The right side is 0, we are having three variables C1, C2, and C3. Now we will be finding the rank of this one. That means below this diagonal, we will try to make these three elements as 0. Now to do that, what we will be doing, this is 1, this is also 1, we will subtract, that is R2 minus R1. And to make this 0, that element is 2, to make this 2 as 0, we will be doing R3 minus 2 times of R1. Let us do that operation. R2 and R3 we are changing, so R1 will remain as it is. We will copy paste R1 first, and then we remain same. Row number 1 will remain same. 1 minus 3, 2, C1, C2 and C3. This will be 0. Now I will create some rough space for the calculation purpose. Part here, that is R2 minus R1. R2 elements are 1, 2 and 4 and 0. R1 elements are 1 minus 3 and 2 and 0. We are subtracting, so sign will change. This will be 1 minus 1 is 0, 2 plus 3 is 5, 4 minus 2 is 2, and this 0 minus 0 is 0. We got the new row number of 2, that is 0, 5, 2 and 0. Now we'll be doing operation on third row, that is R3 minus 2 times of R1. R3 elements are 2, 4, 8 and 0. 2 times of R1 will be multiplying this R1 by 2, so it will be 2 minus 6. Sorry, I think some 2 times of, okay, it is 2 minus 6 and we will be multiplying 2 to the 4. This will become 0. Now we will subtract, so sign will change. So it is going to be 0, this is going to be 4 plus 6 is 10, 8 minus 4 is 4, this is 0, so we got new row as a 0, 10, 4 and 0. Now again we will draw a line below the diagonal. This is, these two are 0, only this number, that is 10 is not 0, we have to make that a 0, above that is this 5, we will be using that. So it is going to be R3 minus 5 to the 10. If you multiply row number 2 by 2, that corresponding element will become 10. So 2 times of R2. Now R3 is changing, so R1 and R2 will remain same. We will do the copy paste of that part. Let us simplify that. R1 and R2 first we copy that. 1 minus 3, 2, C1, C2 and C3, that is 0 here. Now 0, sorry, row number 2 will remain same. 0, 5, 2 and here 0. Now operation is on row number 3. Let us do that. R3 minus 2 times of R1. R3 minus 2 times of R1. R3 elements are 0, 10, 4, 0. 2 times of R1. Sorry, it is 2 times of R2. So 2 times of R2 will be 0, 10, 4 and 0. We will subtract and we will change. 0 minus 0 is 0, 10 minus 10 is 0, 4 minus 4 is 0 and 0 minus 0 is 0. So we got 0, 0, 0 and 0. Now if we look at the rank, the first row is non-zero row. R1, that is not equal to 0 row. R2 is also not 0, but R3 is 0 row. Is it clear? So rank of this augment, this matrix, we call it the coefficient matrix. Rank of A is equal to 2. Number of variables is equal to 3. Here rank is less than the number of variables. That means this equation will have infinite solution. And we say that the given system of given vectors from which we have made this matrix, is going to be linearly dependent. Since rank of A, rank A is not equal to number of variables, therefore the given set of vectors are linearly dependent. Is it clear? So if rank of this matrix becomes 3, that is equal to the number of variables. In that case, it will be linearly independent. becomes less than the number of variables, in that case it is going to be linearly dependent. I hope you have understood this one. Next time we will have one more sum based on this to have a more clear idea about how to check whether the given system of vectors are linearly dependent or independent using the concept of rank, that is using the concept of matrices.